Welcome to another episode of Earth is Our Home. Today we're going to be looking at what questions the public may have about global warming with Dr. Thomas Blaine. So stay tuned. Welcome to another episode of Earth is Our Home. Today, Dr. Thomas Blaine, who is an environmental economist, who's going to be talking about questions that you, the public, have about global warming. Tom, it's great to be able to co-host with you. Tell the viewing audience a little bit about yourself, if you would.
Well, thank you, Patrick. Thanks a lot for having me. I am Thomas Blaine. I was born in Ashland, Kentucky, right there in Boyd County, Kentucky, along the Ohio River. Grew up in Russell, over in Greenup County. I studied at the University of Kentucky. I received a Ph.D. in environmental economics there. I took a position at Texas A&M University, where I was in teaching and research. Not only did I miss these parts, Ohio, Kentucky area down there, I enjoyed my time there, but I was in a teaching and research position. And I became acquainted with the extension at Texas A&M. And I realized that even though I was glad for the experience I had teaching and research in a typical academic department, that what the extension folks were doing in outreach really appealed to me a lot. And so I applied for a position at OSU Extension and received a position. Been working here for 26 years and change as an outreach educator. I still teach a lot. I still do a lot of research, but I'm in extension and very proud of it.
You know, this is an interesting topic. Earth is our home, and some of the questions, it seems to me that for everyone that I meet, everyone has a little bit of a different philosophy about global warming.
Yes.
And I'm hoping that maybe you're able to help unconfuse individuals about what global warming is.
Well, that's what I'm going to try to do over the next couple of presentations that we do. I'm going to get started today, but I don't intend to complete it today. And the reason that I don't intend to complete it today is that I want to get into some detail so that people get an understanding. You know, it's a topic that has been one of the primary environmental topics in the world, even the name. Back when I started doing this topic, global warming was the term. And it's almost become a no-no to say global warming now. It's global climate change now. I don't want to get hung up on those. We can talk about warming in terms of observed temperatures. It's much easier to observe temperatures than it is to observe climate. But we will talk about both aspects as we move forward. And I just hope I'm going to present what I think are the unanswered questions the public has. And I think that this is going to satisfy a lot of people to say, all right, I've now heard some answers and discussion about the questions that my friends, colleagues, and I have expressed. That's what I would like to do in these episodes right now as we begin Earth is Our Home. And then, of course, we'll be moving on to a number of other really important environmental topics, but we'll always come back to this. But I'm going to be talking about global climate change, also known as global warming. Talk a little bit about the distinction between those two. For those of you who might not know me, I've been with OSU Extension since 1995. And from the very beginning, I began writing. So what I want to do here is address some questions that the public has about global warming, climate change, that most people in the public just do not believe have been answered very well by scientists. This is very important to me because in outreach, I want to answer the questions that people have about these topics. The first one is, isn't it true that Earth has been much warmer in the past? Of course, the answer to that is yes. So somebody reads, for example, that global temperatures have risen about 1.5 degrees Fahrenheit in the past 100 or 110 years. And then they read that Earth's temperature has been much warmer than it is now in the past. They have several questions. One is, if it's true that Earth's been a lot warmer and we've warmed 1.5 degrees Fahrenheit in the past 110 years, what's the problem with that? Why is that a problem? If we're going to warm another even 3 to 4 degrees Fahrenheit by 2100, why is that a big deal? Because we've been warmer than that. Well, it is a big deal. That is a huge deal. If we get to 3 to 4 degrees warmer by 2100, that is a huge deal. And I will explain why. Also, I want to explain to you how those natural changes occurred, because people are questioning, if these changes occurred before, aren't the warming and cooling patterns natural? Isn't that just Earth's normal cycle of warming and cooling? So I want to teach you about the cycles of warming and cooling, and then explain how today's warming is different than that. And I want you to know about Earth's climate history. That's what we're going to delve into today. What reason is there to believe that the current warming is man-made instead of natural? We won't get that to that today, but this is for the future as we continue over the next few episodes to address this very important and somewhat complicated issue of global climate change in general and global warming in particular. Where did the idea first come from that humans could influence the temperature of the planet? Who came up with that? You're going to be surprised. Scientists began studying this in the 1880s and 1890s. And I'm going to talk to you after we go through some of this data, who those scientists were long before this became a political issue, long before it became an issue among the general public at all. Nobel Prize winning people that would go on to win the Nobel Prize in chemistry for topics unrelated to warming were already putting out information that the burning of fossil fuels that we're engaging in would lead to significant global warming. So we're going to go through all these questions, and I want you to look at those. I would guess if you're watching this program, these questions have come up to you, and you may have discussed them with your friends. But chances are you don't have good answers to these, and that's what I'm hoping to give you as we go forward. I want you to be sure to read my global warming fact sheet, because it covers a lot of the ground that we're covering today. The latest update I have on the fact sheet is 2020, so it's pretty current. But if you just Google that, Thomas Blaine, global climate change, Ohio State extension fact sheet, or any of those words like that, you really won't have any trouble finding it. And it's a good read. It's got a lot of the graphs in it and talks about a lot of the material that we're going to go through now. So I really encourage you to read that, share it, send the link to your friends and colleagues, because again, it's something that's going to answer a lot of these questions that you have. If you look way out to the right, down at the bottom, that 0 means 0 years ago. That's the present. And as you can see, the temperature at the present is down at the bottom. In fact, it's about 12 degrees Celsius. And that's in the upper 50s Fahrenheit, that's the average surface temperature on planet Earth right now is in the upper 50s, 59 or so degrees. And it's been in a range around that now for the last couple million years at least. But when you then look at the graph, you notice that for much of this 600 million years ago, Earth's temperature was 10 degrees warmer than it is now. So 12 degrees Celsius as opposed to 22 degrees Celsius, which is about 18 degrees Fahrenheit, 18 degrees Fahrenheit warmer than it is now. If you go back, let's go up where we've cooled over the last 30 million years and go back up and look in between the 0 and 100 million years ago, where it was up around 22 degrees Celsius in there. Tyrannosaurus Rex ruled the earth and definitely ruled the northwestern, what is now the northwestern United States. There was an inland sea. And Ohio's climate back then, the land that would become Ohio, was basically hot and humid year round. It was like the climate in the tropics in the Amazon or some place like that, a very hot, humid environment year round. There were no glaciers on planet Earth. There was no snow. It was a completely different planet Earth than what we know of now at 18 degrees Fahrenheit. So in other words, I want you to get that in your mind, first of all. When people talk about transforming the earth, we're not talking about a 20, 30, 40 degree Fahrenheit difference. We're talking 18 degrees Fahrenheit is enough to transfer the world we have now into a place where every place on earth has essentially a hot, humid, tropical type environment. Now, you see these fluctuations. You may wonder why I started at 600 million years ago. Well, 600 million years ago, just really technically speaking, 542 million. There's a little glitch in the aging there, the timing, but that's the beginning of our eon. Our eon is the Phanerozoic eon. And Phanerozoic just means animals that are big enough that we could see with our naked eye. Prior to this, prior to 600 million years ago, all life on Earth was microscopic. There was no large-scale life. We started getting multicellular organisms way back before that, but then we started to see natural selection began to favor organisms that were more complicated, that had specialization of shells, and they grew in size over, millions of generations. And by the time you get to 600 million years ago, you have animals that were large enough to see with the naked eye, but they didn't have bony structures, skeletons. That came along about 542 million years ago. That's called the Cambrian Explosion. And that's when typically the Phanerozoic eon begins. As you can see, we've almost got a bipolar situation. Earth will be up there in the hothouse, and then something will cause it to cool down to what we have now. By about 450 million years ago, the heat wave had ended, and Earth went into a cold episode like we have now. And then it warmed up. So what caused these changes? The bouncing back and forth. And it turns out that what causes these changes is whether or not warm, tropical, equatorial ocean waters can flow up over the poles. If warm water can flow unimpeded from the equator to the poles, you're going to have a hothouse Earth. You're going to have the Earth that's 22 degrees Fahrenheit because the poles receive the least amount of sun. Or if the poles can't cool down because we've got warm water there, then no place can cool down. Right now, we're in a cold house, as you can see, 12 degrees. What's happened? Think about it. Think about the way the Earth looks now. Continental drift has put Antarctica right over the South Pole. Warm equatorial water can't get anywhere near the South Pole because of Antarctica. That's not the norm in Earth's history. Continental drift, rearranging continents. The continents move at about the rate at which your fingernails grow. 100 million years ago, the continents were arrayed in such a way that warm ocean water, let's go back just this side of 100 million years ago, 80 to 70 million years ago, you can see that at a warm Earth, the continents were arrayed in such a way that water could flow unimpeded over the North Pole, over the South Pole, and it prevented global cooling. Now, Antarctica in the South, look at the North Pole. You've got the Arctic Ocean, so you don't have a continent, but warm equatorial water can't get anywhere near the North Pole because of Eurasia, North America, Greenland. The Arctic Ocean is pretty well separated from the warm waters of the Atlantic, the Pacific, and the Indian Ocean. And that's what has caused the gigantic cooling that we've seen over the last 30 million years that has put us in the ice house that we're in and have been in for the last really few million years. So yes, that cooling is natural. The warming is natural. No question about that. But I also want you to remember the 18 degrees Fahrenheit. If we look at what happens within the ice house that we're in, Earth's climate fluctuates in 100,000 year cycles that are caused by fluctuation in its orbit around the sun, called Milankovitch cycles. During the past million years, Earth has generally been a lot colder than it is now. Ice ages come and go about every 100,000 years. So if we look, again, way out on the right, 0 years ago, we're up at 0, which means 0 deviation from the present. But look what it was like 25,000 or so years ago. Go to the left a little bit. That's the time I was talking about when I said Northern Ohio was under an ice sheet a mile thick. And that was the Ice Age. These come and go. These are natural. Humans didn't have anything to do with this. But I also want you to notice something else. The coldest that Ice Age got, a mountain of ice in Ohio, you wouldn't have been able to find a tree anywhere near this part of the world. You'd have to go all the way down near the Gulf Coast to find a tree. It was too cold to support trees. Kentucky, Tennessee, they were like Arctic tundra. It was so cold. And yet Earth's temperature was only 5 degrees Celsius. That's about 9 degrees Fahrenheit cooler than it is now. So if 9 degrees Fahrenheit separates us and the Earth we have today from an ice age where we could not have the life we have, Chicago would be run over. Cleveland would be run over. Detroit, run over. Much of Ohio by a mountain of ice a mile thick, even at 9 degrees Fahrenheit cooler globally. So when you hear people talking that we've already warmed 1.5 degrees Fahrenheit, that's well on the way to a 9-degree warming that would transform the Earth into something that humans have no experience with. modern humans certainly have no experience with. We've configured an Earth that is made for the kind of temperatures that we've had really just in the past 2,000, 3,000 years since we initiated civilization. So I hope this gives you a little bit of perspective on temperature changes, climate changes. Yes, they've been natural. Some caused by continental drift, where the continents are. Some caused by the changes in Earth's orbit around the sun that occur at regular intervals. They're natural. And so I wanted to definitely answer a couple of those questions. And I hope you'll join me for the next episode when we will continue with these questions and maybe review some of what we did today and then go on to more current temperatures and reasons to believe that the current warming we're seeing is in fact man-made.
Tom, this is an interesting graph. It does show over 800,000 years. One of the things that I notice when it comes to Earth changing, that it's over a long period of time. For instance, 4 or 5 million years ago, we had seen a dramatic change from -5 up to our current temperature of 0. So why should we be concerned now when the change is very, very gradual?
Okay, so that bottom that you're talking about is 25,000 years ago.
Oh, 25. Okay.
Yeah,
yes.
what we've done now, we went from millions, and now we've expanded that little section that was way out in the bottom right of the big graph, and that graph was smoothed out. And you can't put too many changes in a graph, so that was smoothed to like 5 to 10 million year averages. Then once you get into a period of 1 million years, you'll see a fluctuation like this. Yes, 25,000 years, we've had a warming of about 9 degrees Fahrenheit that ended the Ice Age, melted all the glaciers in Ohio, drove them all the way up to the Arctic, etc. Well, you're asking, if this took place over a long period of time, what problem is that? Well, I'm going over the natural warming and cooling phases. There's not much we can do about these anyway. I'm setting this up to talk to you about the man-made changes, because once we get into the man-made changes in temperature, we're going to see that they're much more rapid. In other words, the point is, as you say, it took about 25,000 years to warm up 9 degrees, right? 25,000 years to go up 9 degrees.
Yes.
There are scenarios now that if we continue with fossil fuels and population keeps growing, that we could have a 9-degree Fahrenheit warming caused by humans in just 100 years, the next 100 years. So in other words, a rapid warming like that, nature tends not to produce that. That's one of the points I wanted to make when I said, yes, nature has produced warming and cooling trends. But as you point out, they tend to be over long periods of time. But humans are producing a warming trend now that is not over a long period of time. And that means that adapting will be a real challenge, if not impossible.
And that's where your economics background comes in, because I'm assuming if we make a major change to the Earth in a very short period of time, it'll probably have a detriment to our economic systems. Is that correct?
That's absolutely correct, because we've configured the whole Earth to satisfy our needs. We live in artificial environments. We have air conditioning and heating. We can get into a metal tube called an automobile and drive all the way across the continent on pavement that we've erected there with exits where you can stop and get food and everything you need. I mean, we've configured the whole Earth airports. You can fly to Europe in a few hours, South America. We've configured the Earth, and most of this configuration's been done just in the past 100 to 200 years. And we've configured it on the basis of a lot of factors, including the kind of climate that we have now. If the climate changes, the apparatus that we've set up from agriculture to transportation will be jeopardized.
Well, that's really interesting. I'm looking forward to learning more. I know one thing, that human beings tend to be adaptable.
Yes.
And that since we don't see the warming of the earth, but on a gradual basis, I often hear individuals say, well, we can adapt to that.
Yes. Well, it's one thing to adapt to, a 5 degree Celsius, which is 9 degree Fahrenheit warming that takes place over thousands of years. It's one thing to adapt to that, but it's another thing to adapt to that same kind of temperature change that occurs over 100 years. The greater the shock, the more difficult in adapting. I'm not saying we can't adapt either. I'm not saying, but I'm saying that, we don't know either. It's easy for me to go and show you past temperatures. But when I talk about where the future temperatures are going to go, we're trying to learn from the past to apply it to the future. That's what science does. But we don't know exactly what it's going to be. But I can guarantee you that it's much easier to adapt to a 9 degree Fahrenheit increase in temperatures over several thousand years than it is to do it over a period of 100 years.
Well, I'm very much looking forward to our next Earth is Our Home telecast. Again, we're talking with Dr. Thomas Blaine. He's an environmental economist with the Ohio State University Extension Program. We'll also put at the bottom where you can reach his fact sheet. Tom, thank you.
You're sure welcome.